A cell of EMF 4 volt, a cell of EMF 4 volt and internal resistance 0.5 ohm, internal resistance 0.5 ohm, is connected across a load resistance one 7.5 ohm and 2 7.5 ohm 11.5 ohm. Calculate first one, the ratio of differences in the EMF, the ratio of differences in the EMF of the cell and the potential drop across the load. Potential drop across the load. And the second one, the ratio of the currents in the two cases. Ratio of the currents in the two cases. First, let us read once again. A cell of EMF 4 volt and internal resistance 0.45 ohm is connected across a load resistance 7.5 ohm and 11.5 ohm. Calculate the ratio of differences in the EMF of the cell and a potential drop across the load and the ratio of the currents in the two cases. Now first case, we have two loads here, that is 7.5 ohm and 11.5 ohm. First we need to find out the ratio of differences in the EMF of the cell and the potential drop across the load. That is we need to find out E minus V in both the cases. That is when we have two different loads, find out what is E minus V, that is EMF minus potential difference. Then calculate the ratio. First we will calculate E minus V in both the cases. Let us write the given things. Given the EMF of the cell E is equal to 4 volt. The internal resistance of the cell, that is small r, is 0.5 ohm. And if V is the potential difference, we know that E, like we have an EMF source, we have external resistance R, and this is EMF E with internal resistance R. The PD V is given by, so the EMF of the cell is always equal to potential difference plus I into R. Or in this case what we need is the difference in the EMF of the cell and the potential drops. So we can write the difference between EMF and potential drop as I into R. So once we find the current in the circuit, we can easily find out what is E minus V. So first let us calculate the current in both the cases. Case 1. The load resistance R is equal to 7.5 ohm. So in this case current I1 is equal to E divided by R plus R, which is equal to, the EMF is same, 4 divided by 7.5 plus R, internal resistance is 0.5. This will be 4 by 8, half amps. Now what is E minus V? Is I into R. E minus V will be equal to I1 into R. This will be equal to half into 0.5, or I can write this as 1 by 4 volt, because 0.5 is half, so it is 1 by 4 volt. Now same calculation let us do for case 2. Case 2, where R is the load. The load is now changed to 11.5 ohm. Therefore I2 will be equal to E divided by R plus R, which is equal to 4 divided by 0.5 plus the capital R is 11.5. Four by 12 or equal to 1 by 3 amps. So now E minus V in this case will be equal to I2 into R. One by 3 into 0.5. This 0.5 is actually half, so it is equal to 1 by 6 volt. Now we can write the answer for the two questions. The first question is the ratio of differences in the EMF of the cell and the potential drop across the load. So therefore we can write answer for question. The ratio of differences in the EMF of the cell and potential difference across the load is equal to The value is I1 by R divided by I2 by R. So this is equal to 1 by 4 divided by 1 by 6. 6 by 4, or it is equal to 3 by 2. And there is no unit because it is the ratio of two voltages. The second question asks us to find out the ratio of currents in the two cases. The ratio of currents in the two cases as I1 by I2. Which is equal to half. I1 is half and I2 is 1 by 3. Half divided by 1 by 3, or equal to 3 by 2. Again no unit because it is the ratio of two currents. So with this we get the answer for both the ratio of differences in the EMF of the cell and the potential drop across the cell, and also the ratio of current in two cases. This is the answer. The ratio of differences in the EMF of the cell and potential drop across the load is I1R by I2R, which is actually equal to E minus V1 divided by E minus V2. And the ratio of currents in two cases. Find out current in two cases and then find the ratio.